you can actually deduce that x is equal to r cos theta. Are we together? Comparing to, and y is equal to r sine theta. That's easy to see. From the Pythagoras theorem, that's easy to see. Now, you remember very well, if this is my z, this is my angle theta, angle of inclination, right? And this is my r, as in what? My modulus, my magnitude, isn't it? This can be likened to the modulus of z like this. Now, this is 90 degrees, and this is y, this is x. Another way of writing this is to use trig functions. You know that cos theta, what is cos theta equal to? Adjacent over hypotenuse. So it's according to this diagram, cos theta is what? X over r, which further implies that x is equal to r cos theta. Agreed? You can make x the subject of the formula. So where there is x, I can actually replace with what? Cos theta. You understand? It's the same thing in polar form. Okay? Sine theta is opposite of hypotenuse. Which one is the opposite? Y over r. This further implies that y is equal to what? R sine theta. So originally we had a complex number written in rectangular form as what? As x plus iy. But where there is x, I'm going to put what? R cos theta plus I. Where there is y, I'm going to put what? R sine theta. I can factorize the R because already we are here. So we can say this is cos theta plus I sine theta. So this form and this form are the same. But what is this form called? Modulus augment form. Because it has got the modulus of the complex number and it has got the augment, which is the angle theta of the complex number. So it's called the modulus augment form. And this is where it's coming from. It's not necessarily like a complicated version. It's just showing us where these formulas are emanating from. You understand? So that's another form you need to get used to now. The modulus augment form. Two forms of writing a complex number. Actually, we've got three. I will introduce the third one, but not now. Perhaps in year 13. Okay? Actually, in year 13. So that's the other form. And this is where it's coming from. Not really to worry. Okay? Any questions? No. Because by now already you know this. You should actually have known this already. That when I can replace the x with r cos theta. And I can replace the y with r sine theta. Have you ever seen this when you're doing trigonometry? Did your teachers ever speak about this? No? And they said this is equal to? No? All right, fine, we'll get there. But they should have said it. Okay? All right, let's move on. Good example. So you're given the rectangular form. Your duty here is to write the modulus augment form. So perhaps to start with drawing your organ diagram is important because we are saying it's not up to scale actually. I'm just going to place it wherever I feel like because I can't find a way of writing √3 on a boxed way accurately. I'm just going to place it where I want. So I'm going to write it here and I'm going to draw it as Z. What does this mean? This means this part here is what? from here to here is minus root of 3. Or rather, it's just not minus, because already I know it's minus. Why would I write? I know this side is negative, isn't it? So the magnitude is just root of 3. Okay, and here it's 1. Are we together? And this angle, let me call it what? Alpha, because we want to calculate. Let me call this angle alpha. The actual angle we want is not this one. Have you realized that? Which one do we want? We actually want from the positive. You remember we said the angle is always between the positive real axis with the complex number. So with the vector here, it's this angle. This is the angle we want from here to there. But we can calculate this one for us to tell what is this one. Okay? So first of all, we need R. R is easy to find. What's R? R is just the square root of this, isn't it? R is just the square root of this, which is minus root of 3 squared plus 1 squared, which is going to be equal to root of 3 squared is 3 plus 1, so it's thus 4. So the answer is 2.
Or is the root of 3 minus? So it will be minus 3.
The squared, the minus, you're saying like this.
Oh, because it's squared, yeah.
So it's just 3, right? 3 plus 1, 4. So R is 2. Okay? Second, we want to find theta. So how do we find theta? We say the angles here, we can just write them as pi minus alpha. Simple. So in this case, I'm going to say the log of z is pi minus what? Minus alpha. But how do we find alpha? Tan inverse of 1 over 3. Yeah, that's it. I mean, that's a special angle. Tan 1 over 3 is a special angle. So it's pi minus, minus like this. It's pi over 6. 1 over 3 is pi over 6. It's a special angle. So this is actually equal to 5 pi over 6. You see that? So this argument of z is 5 pi over 6. Therefore, what is z in org form? Z should be written as r cos theta plus I sine theta. But we know r is what? 2 bracket cos. We know pi, theta is 5 pi over 6 plus I sine 5 pi over 6. That's it. You get it? All right? Let's quickly do the last one, then you can go home and rest. Okay, we have another lesson tomorrow. All right, next one. Look at this example. So this is going to be z, which is minus 1 minus I. Essentially telling us that this is 1, this is 1. I'm talking about the magnitude. Okay? We are interested with theta, so let's call this angle what? Alpha. Are we together? How do we find R? That's straightforward. R is equal to, which is the modulus of Z, is equal to the square root of minus 1 of 1 actually, squared plus minus 1 squared. So the answer is just going to be root of 2, isn't it? How do we find the angle? We say it's the angles that are in here. We rather write them as what? Alpha minus pi. You get that? So the log of Z is going to be alpha minus pi, or you can just write minus, or you can just write minus pi plus alpha like this. Sorry, minus alpha. Like this, isn't it? So that's it. That's it. But now, how do we find alpha? Alpha is the what? Tan of this triangle, isn't it? Alpha is tan of this triangle, which is y over x. So alpha is tan inverse of 1 over 1 minus pi. You get that? Of which, what is that? That's a special angle. That's a special angle. That's pi over 4 minus pi. So the answer is minus 3 pi over 4. You get that? So these are the 2 points. Therefore, Z is going to be equal to root of 2 cos in bracket minus 3 pi over 4 plus I sine in bracket minus 3 pi over 4. You close your brackets. Right. Yeah. Okay.
That's the end of the day. Have a good afternoon.